Okay, so we started by just learning like qualitatively what freezing point depression is and boiling point elevation. So now we're going to learn how to quantify it. Okay, so like by how much is the freezing point going to drop, or by how much is the boiling point going to increase? So these colligative properties, they just depend on this ratio of solute to solvent particles. So the first thing we have to calculate is something called molality. Okay, so molality is just the ratio of solute to solvent. Okay, so our formula for finding molality is our moles of the solute divided by kilograms of the solvent. So go ahead and copy down this equation. And then for molality, its symbol is going to be a lowercase m. Okay, so go ahead and write that down. So lowercase m is moles of solute divided by kilograms of solvent. We're going to do 2 practice problems on calculating molality. So the first one is, what's the molality of a solution that contains 25 grams of glucose dissolved in 200 grams of water? So our equation for molality is going to be little m. And then what did we write in the numerator on the previous slide? Hold it, just like words. On the previous slide, what goes in the numerator?
That would be moles of solute.
Okay, so we're going to take moles of solute. And then what do we divide that by?
Yep.
Kilograms of solvent. Okay, so then if we look at the word problem, are we given moles of the solute? Okay, what are you given though? Grams. So can we figure out our moles? Okay. Okay, how do we get from grams to moles? Okay, molar mass. So we all find the molar mass of C6H12O6. Do y'all agree?
Yep.
180.18? Yeah. Okay, so now let's just divide. What's 25 divided by 180.18? Yeah, it should be little.
0.138.
0.138?
Yeah, 0.138.
139, we'll round it up.
Okay.
Okay, so that's our moles. And then how much solvent or how much water is it dissolved in? 200. Okay, 200 grams. And what unit does that have to be in?
Kilograms.
Okay, so how do we get from grams to kilograms? Okay, so one option is divide by 1,000. Can you actually type that in your calculator and divide it?
Yeah.
Okay, that's one option. What's the other option? Okay, move the decimal 3 places, to the left or right. Go 3 to the left. Okay, so 200 grams becomes how many kilograms? Okay, 0.200. So now I'm just going to plug it in. So our moles is 0.139. And our kilograms is going to be 0.2000 kilograms. Okay, so now from here we can just divide. So what's 0.139 divided by 0.2? 0.695. Thank you. Okay. And your unit can just be a little m for molality. Okay, this time we're going to figure out what mass of sodium chloride must be dissolved in 500 grams of water to create a 0.75 molal solution. So we're still going to use the molality equation. So molality is going to be moles, I'm going to say per kilogram. So then if you look at the word problem, you get two of these variables. So our first number is 500 grams. Where is that going to be used in this equation? Okay, so this is going to be our solvent. Okay. So we know we're going to use that one here. And then what's the other number given? Okay, so this 0.75 molal is the molality. Okay. So then by deductive reasoning, what are we going to solve for first? Okay, so we're going to solve for moles first. How can we rearrange this to solve for moles? Okay, so I'm going to say m times kilograms. Okay, so now I'm going to plug in the 0.75. And remember, molality is moles divided by kilograms, which I'm just going to write the units so you can see how they cancel. Okay. And then 500 grams becomes how many kilograms? Okay, so it becomes 0.5000 kilograms. So now let's multiply. What's 0.75 times 0.5? Is it 3.75? 0.375. Okay, and notice kilograms canceled, so your only unit that didn't cancel is moles. And in this case, it's moles of the sodium chloride. And then if we read the word problem, does it want your answer in moles?
Wait.
Okay. What does your answer need to be in? Grams. So what mass means what grams? So now we just are going to take our moles and convert them to grams. Okay. So we know there's going to be 0.375 moles of NaCl in this solution. How do we get from moles to grams? Okay, we all find the molar mass of NaCl. Okay. So we're getting 58.44 grams. Okay, now we just multiply. So what's 0.375 times 58.44? You're saying 21. Okay, I'm going to keep it as just 21.9. We'll say grams of NaCl. Okay, so now let's move forward. And how do we use molality to calculate the boiling point change? Okay. I'm going to rewrite the equation. So write what I write. So to figure out the change in boiling point, we're going to do this delta capital T, so like how much the temperature changes, and the little b is boiling point. Okay. So then that's going to be equal to K, and the b is like a little subscript b. Okay, so KB times lowercase m. So copy that equation down in your notes. So then the delta TB, it's the boiling point, and I have a little typo here. It's not depression, it's elevation. Okay. And that just means, well, how much is the boiling point actually going to change? The KB is this molal boiling point constant. This number will always be given to you. Okay, so I'll always give you KB. And then little m is molality, which is what we just learned how to calculate in our previous couple slides. Okay, so sometimes you're asked just to calculate like the boiling point elevation, so how much it changes. Other times you're asked to find like the total like new boiling point. So to get the new boiling point, you're just going to take the boiling point of the pure solvent. And then since it's elevation, it's going up, you're going to add whatever that change in the boiling point is. And then most of the time, the pure solvent's going to be water. What's the boiling point of water? in Celsius. Yeah. Okay, so just boiling point of pure water is going to be 100 degrees Celsius. Okay. Let's do one practice problem together. So we're going to calculate the boiling point of a solution of 1.5 moles of glucose in 500 grams of water. And then the Kb value for water is 0.512. So when we want to calculate the boiling point, we'll use that new equation. So the change in the boiling point is going to be equal to that boiling point constant times molality. So we're going to be solving for the delta TB. Okay. The KB is this value, so it's just given to you. Okay. So that means we just have to find molality, and then we can just plug it in. So off to the side, let's solve for molality. Okay. What goes in the numerator for molality?
That would be the moles of solute.
Good. The moles, and how many moles of solute? Okay, so we're going to do 1.5 moles. And then what goes in the denominator? 0.5. Okay, the 0.5. So remember, you have to convert your 500 grams to kilograms, so it'll become the 0.500 kilograms. Okay, so then what's 1.5 divided by 0.5?
3.
Okay, 3. I'm going to just start at 3.0 to keep it sig friendly. And we're just going to say little m for molality. Okay, so now we know Kb and we know m. Can we just plug them into the equation? Okay. All right, so Kb is this 0.512 in the degrees Celsius divided by molality. And then we'll multiply it by 3.0. So then in our calculator, we're just going to type in 0.512 times 3.0. $1.54. Thank you. Okay. And then notice the little m's for molality cancel. So then the only unit that didn't cancel is degrees Celsius. Okay. So that means by adding this glucose, we've raised the boiling point 1.54 degrees Celsius. Okay. So now to get the total boiling point, what's the normal boiling point of water? Okay, so 100 degrees Celsius, and then we're just going to add this 1.54 degrees Celsius to it. So what's the new boiling point? Good. Okay, so then the solution's boiling point is 101.54. Okay, next we're going to look at the freezing point depression. So this equation is pretty much the same. So delta T with the little subscript F is just how much is the freezing point going to change. And that's going to be equal to Kf times M. So go ahead and write down the freezing point depression equation. So the delta Tf is still just freezing point depression. Okay, so that change in temperature. The Kf is just the molal freezing point constant. Again, I will always give you Kf. And then M is still molality. All right, and then if we want to find the new freezing point of the solution, we'll just take the freezing point of the pure solvent. And then this time, since it's depression, we're going to subtract that change in freezing point. And most of the time, our solvent's going to be water. What's the freezing point of water in Celsius? Okay.
Oh, wait, no. That was.
So water's going to freeze at 0. Okay. So then we'll just subtract our value from 0 as long as water is the solvent. Okay, so let's do one practice problem for freezing point depression. Okay. So let's calculate the freezing point of a solution with 2 moles of sucrose in 500 grams of water. The Kf value for water is 1.86. So this time we'll use the freezing point depression equation. Okay. And that's going to be equal to Kf times m. So we're going to solve for the change in the temperature. Kf is given to you, so now we just have to find the molality. Okay. So again, off to the side, let's calculate the molality. Okay. What goes in the numerator? Okay. So we'll put our moles. So 2 moles in the top. What goes in the denominator? Okay. That 500 grams, remember to convert to kilograms, so we get the 0.5 kilograms. What's 2 divided by 0.5? Okay. So we just get 4, and I'm going to say m for molality. So now we can just plug our numbers in. So Kf is 1.86, and then our molality is 4. What's 1.86 times 4? 7.4. Okay, and so then the last step is to calculate the freezing point. What's the freezing point of water? Okay, so it's 0 minus 7.4. So then the new freezing point of the solution is negative 7.4 degrees Celsius.